Sir, namaste. We are audible.
Yes, ma'am. Am I audible?
Yeah.
Yeah. Okay. So, hi everyone. I hope you'll be fine. I can see Ramdev there, but I don't know much names. Sorry for others. All right. So we completed trigonometry in the last class, right? If I'm not wrong, we did trigonometric functions, ratios, graphs, equations, everything, isn't it? Isn't it? Yes. All right. All right. All right. So today we'll be starting with permutations. But I personally feel like to start with permutations. Do you want me to start with any other chapter? If you want to recommend any other chapter, I'll be starting with that. Shall I start with permutations? Okay. You have revised it? All right. We'll be solving questions related to that. No problem. Good. Okay. So with a fresh mindset, let us start with permutations. Before entering into permutations, what we should know is about factorials. Okay, factorial notations. You know what is factorials? Right? Let n be a positive integer. Positive integer. Then the continued. Then the continued product of first and natural number. Continued product of first and natural number. First and natural number is called factorial n. Is called factorial n. Or it is denoted by n like this or n factorial like this. Understood? Okay. 0 factorial is what? Do you know that? 0 factorial? 1. Very good. Good. Okay. So this was the basic around that. Let us start with some questions. Can you solve me and find the values of this equation? 10 factorial by 7 factorial into 3 factorial. Can you find that value? Can you find this value? 120. Very good. 120 is the correct answer. Okay. How to do that? So easily you can do 10 into 9 into 8 into 7 factorial divided by 7 factorial into 3 factorial. So 7 factorial can be cancelled out from here. 3 factorial is nothing but 8 by 3 into 2 into 1. So 3, 2, 4. So this will become 120. Right? Okay. Next question. If x upon 10 factorial is equals to 1 by 8 factorial plus 1 by 9 factorial, can you find x? Do this.
Sir.
100 you got? That's correct. Good, good, good. So x is what? 10 factorial upon 8 factorial plus 10 factorial upon 9 factorial, right? It will be 10 into 9 into 8 factorial by 8 factorial plus 10 into 9 factorial by 9 factorial. So this will get cancelled, this will get cancelled. It will be 90 plus 10, that is 100. Good. You're going great. Okay, another question. If n plus 1 factorial is equals to 90 into n minus 1 factorial, find n. Any answers? How much? I could not hear you. 10. Are you saying 10? 10 is wrong, 9 is correct. Who said 9? 9 is correct. Okay. So n plus 1 factorial is equals to 90 times n minus 1 factorial. I can write it like n plus 1, then another number will be n, another number will be n minus 1 factorial and continued is equals to 90 into n minus 1 factorial. This will get cancelled. It will be n square plus n is equals to 90, or n square plus n minus 90 is equals to 0. Okay, you can solve it further. After that, you just have to factorize it. What will it become? N square plus 10 minus 9 minus 90 is equals to 0. Right? So n into n plus 10 minus 9 into n plus 10 is equals to 0. So n plus 10 into n minus 9 is equals to 0. So n will be either minus 10 or plus 9. Negative number is invalid here in terms of n. It will be plus 9 only. Okay. So this was some questions related to the okay, one more thing. Find LCM of 5 factorial, 6 factorial, and 7 factorial. Can you do this? Yeah. No. No. Yeah.
What is that?
How much?
5040.
5040.
Yes, sir.
I'll have to think. Wait a minute. I have the answer in different notation actually. Just let me check. Give me 1 minute. Yeah, that's correct. That's correct. So here basically what you have to do here, you don't have to do that much calculation. It is 1 by 5 factorial and 1 by 6 factorial and 1 by 7 factorial. How to take out the LCM? First, can I write it like 1 by 5 factorial, 1 by 5 factorial into 6, 1 by 5 factorial into 6 into 7. So now can I take 1 by 5 factorial common and it will be 1 by 1, 1 by 6, 1 by 42, right? So this will be nothing but 1 by 5 factorial, or better I write it like 6 into 7. So what is the LCM here? 6 into 7 is the LCM here. So it will be 6 into 7. Then here it will be 7 by 6 into 7 by 6 into 7. And it will be 1 by 6 into 7. So LCM will be what? 1 by 5 factorial into 6 into 7. So 5 factorial into 6 into 7. That will be what? 7 factorial. This is the LCM. Understood? Did you understand it or not?
Yes, sir.
Good. Okay. Now let us move on to some probability type questions. Okay. Permutation is basically kind of arrangement that you have to do in case of numbers. So first we'll be solving such questions which we'll be solving by permutations later by manual method without knowledge of permutation. Okay. So basically let us say that in a class, I'm just giving an example. In a class, 16 boys and 9 girls are there. Okay, in a class, 16 boys and 9 girls are there. All right. The teacher wants to select. The teacher wants to select a class representative, a CR. You must be having your CR too. In how many ways? In how many ways can the teacher make the selection? Can the teacher make the selection? What are the possibilities? Are you getting my point? So basically there are 16 boys and 9 girls, right? What is the total possibilities? Total possibilities is 25, isn't it? So teacher has 25 options to select any one of it. Understood? So 25 possibilities will be there. 25 random arrangements will be there. That is what we do in permutations. We calculate the total number of possibilities. So this was the easiest one. Now if we add some condition in there, for example, some boys can't be able, can't be made the CR due to some reasons, or some girls can't be made the CR due to some reasons. So in that case it becomes difficult. In that we have to apply the permutation. For example, if I difficult make this kind of question difficult, I'll be giving you another question. In a cinema hall, In a cinema hall, there are three entrance doors. There are three entrance doors and two exit doors.
Anu.
Three entrance, two exit doors. So in how many ways a person can enter and exit? So basically, what you have to do here, see, this is one entrance door, second entrance door, third entrance door, and we have two exit door. This is one exit door, this is two exit door. Okay, so we have a person, and we are finding that what are the possibilities that he can take a particular path. For example, he enters with door one and leaves with door two. There is one possibility. He enters with door one, he leaves with door one. There is one possibility. Again, he enters with door two, leaves with door one possibility. Enters with door two, leaves with door two, one possibility. Then for the third one also one possibility and one possibility. So there are how many possibilities? Basically, six possibilities are there. Are you getting my point? So this is what we calculate in permutation. This question was little bit difficult in the particular two conditions were added from the previous question. But in after all, when you'll be seeing the questions, that will be huge and it cannot be solved with this easy combinations. You have to apply the permutation. I've not explained to you what permutation is right now, but I'm just giving you the idea. We are increasing the level. So it is 3 into 2 possibilities can be there. So in all, 6 possibilities can be there for a particular person to cross the hall. Okay, let us make this question more difficult. Oh, you want to write something? You want to write it?
No, sir.
All right, all right. Let us make this question more difficult. Okay, so I'm asking a question that how many how many nine digit numbers of different digits can be formed? Let me make it quite. How many nine digit numbers can be formed? Subpart one of different digits and second part of same digits or digits if digits can be repeated. Can you solve this? Try to solve this question without the knowledge of permutation. Without the knowledge of permutation, try to solve this question. Can you do this?
Yes, sir.
Try it out.
You have doubt ask.
Sir, first question answer 9 factorial.
How much? 9?
Factorial.
I could not hear you.
9 factorial, sir, first question.
9 factorial. Let me check. No, that's wrong. 9 factorial is wrong. Yeah. First one?
Only 9, sir.
Only 9. No.
Sir, 9 into 10 factorial, sir.
9 into 10 factorial. No. Are you guessing random guesses? Whoever gives me the answer next will give me the reason. Think a little. Okay, everyone, look at here.
Yes,
Everyone, look at here. Look at here. See, if I ask you to make a 9-digit number, okay? If I ask you to make a 9-digit number, so how many numbers can you guess for the first number? If I ask you to place any number here, what are all the numbers you can place it? Tell me.
9 numbers, sir.
9 numbers, sir.
9 numbers. Which 9 numbers?
1 to 9, sir.
1 to 9.
Can you put 0?
No,
Yes,
sir.
sir.
Good. So 9 possibilities are there. Now, what are the possibilities to be kept here? If you are
10,
not
sir.
repeating, this is not repeating.
Yes, sir.
How much?
9, sir.
9. Now can you put 0?
Yes,
No,
sir.
sir.
Yes. Now you can put 0. Now you can put it 0. No problem in the second number. Okay. Now what numbers here?
8, sir.
8. Good. Because one number you have kept here. One is 0, and rest between 0 to 9 only 8 numbers are left. Now what number?
7.
7, 6, 5, 4, 3, 2. So this is 9 into 9 factorial. Understood? Did you understand it?
Yes, sir.
Good.
Ten power 9. 10 power 9. 9 into 9 power 9. 9 into 10 power 9.
Now this you tell me.
Sir, 9 into 10 power 9.
9 into 10 to the power 9.
Power 8, 8, sir.
This you can put 9 numbers, and this you can put 10 numbers. From here, all the 10 numbers can be allowed, right?
10 power,
So 3, 5, 6, 7, 8, 9. Yeah, 9, 10, 10 per 9.
sir.
10 power 8,
Sir,
sir.
9 into 10 power 8, sir.
Why?
8. Okay,
Sir, total 9 digits, sir. 1 digit only 9 is coming, sir.
Here 1 to 9 you can put. Total 9 digits. Here 0 to 10 you can put, na? 0, so 0 to 9. Here 0 to 9, 0 to 9, 0 to 9. So 10 numbers will be there, na?
Sir, no.
Isn't it?
Sir, first digit should be filled by 9 numbers, sir.
First digit 9 numbers. Okay, so 10 to the power 8. Yeah, right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I have made 10 boxes. That's my problem. Okay. That's fine. Understood, everyone? Easy? So this becomes difficult, and this we can easily solve by permutation. All right. This we can easily solve by permutation. Let me give you some more questions. Try to solve this. 4 flags of different colors are given. 4 flags of different colors are given. How many different signals can be generated? Can be generated can be generated if a signal requires the use of 2 flags.
12, sir.
Good. Good, very good. So total 4 into 3, right? 4 different ways and 3 different ways for the remaining 3 flags. That is 12. Good, very good. You're able to solve it. That's good. Let me think. Good question for you. Okay. There are 4 roots between Delhi and Patna. Okay, there are 4 routes. In how many ways? In how many ways can a man go from Delhi to Patna? From Delhi to Patna. In how many different ways? I shall write different ways. From Delhi to Patna and return. And return. If for returning, if for returning we have 3 conditions. Any route is taken. Any route is taken. Option 2. Same route is taken. Same route is taken. Third one. Same route is not taken.
Sir, first one 16, second one 4.
Okay.
Third one
This is
1,
4 into 4, 16. Good.
next one 4, sir.
4 because yeah, because we have 4 possibilities. 1, 2, 3, 4. 1, 2, 3, 4. So if we are going through this way, we have to return through this. Either this or this. This or this. So we just have 4 options. Good. Third one.
12, sir.
Okay, that's good. Because if you are taking any of the 4, we have then 3 options to return. Because we have to leave that the same one, isn't it? This did you understand it, everyone? Everyone tell me, did you understand it?
Yes, sir.
Good. Are you liking this?
Yes, sir.
All right. Write it down. Then I'll change the page. Is it done? Shall I change the slide? Everyone, put a thumbs up if you have written. Okay, good. Next question. How many numbers? How many numbers between 3000 and 2000 can be formed by the numbers 2, 3, 4, 6, 7, 5 when repetitions are not allowed?
20 numbers. Sir, 20 numbers, sir.
No, 30 is wrong. Yeah,
Sir, 60 numbers, sir.
60. Okay, good. Any explanations? Pardon?
Sir, 5 factorial by 2, sir.
Okay. So basically, if we have a number, 4-digit number, what are all the possibilities that we can put? Can we put 3 there in the first place? No. 4, no. 6, no. 7, no. 5, no. Right? Only 2 can be placed. So we just have 3 possibilities, 3 positions to be covered. And we don't have repetitions. So 2 is not allowed now. Isn't it? Are you getting my point? In the second number, what are the possibilities? 5 possibilities. Third number, 4 possibilities, and last 3 possibilities. It will be, sorry, here it will be just one number, that is 2. So it will be 1 into 5 into 4 into 3, that will be 60 numbers. Understood? Okay, let me give you another number. Okay, good question. How many numbers are there between 100 and 1000 which have exactly one of their digits as 7?
Sir. Sir.
Yeah, go on, go on, go on.
Repetition is allowed, sir.
Huh?
Repetition.
Repetitions. Nothing has been said about it. You have to consider 3 cases. The question is exactly like this. You have to consider 3 cases. Find all the possibilities. 72, yeah, that is one case. It will not only be 72. What you have considered that 7 will be at the units place only. That's why you are saying 72. There will be possibilities that 7 is there at the tens place also. There is a possibility that 7 will be there at the hundreds place also. So you have to count that too. We have considered that 7 will be only at units place. Yeah, exactly. For example, 701 is a number. It contains 7 only one time. So there will be not many numbers after it. 702, 703, except for few numbers there. It will be more than 72 now. Think of 3 cases. Case 1, 7 at units place. Case 2, 7 at tens place. Case 3, 7 at hundreds place.
Sir.
Let's solve this. Yeah, go on.
146, sir.
No. Consider no repetitions. Okay, I'm easing it out for you. Consider no repetitions.
Sir.
Yeah,
109, sir.
no. Think about it. I'm giving you 1 more minute.
Sir, 180.
No.
Sir, 216, sir.
No. How much? 640.
640, sir.
No.
640, sir.
No. You must be feeling frustrated, right?
107 left. 997. Okay, 107 left. 697 left. 60 numbers. 700 160%.
One of the answers that I don't know who said that. That was nearly close to the exact answer.
Sir.
Who said 216?
I said, sir.
That is nearly close to the answer. Very much close. Now don't go for random guesses. 215, 217. Don't go like that.
Sir, 240,
No.
sir.
No. No. No.
220, sir.
No.
280, sir.
What you do, everyone select a number from 200 to 300 and then you'll be getting that answer.
Sir, 216.5.
How can it be? How can you create a decimal possibility? How will you fulfill that? How will you like make that 0.5% to do a certain work? Okay, see here. Now I'm doing this. Case one. Case one. When we are considering units place, 7 at units place. What will be the possibility? We have 3 numbers. Okay. Units place it is 7. I have no repetitions. I can place 9 numbers here. I can place 8 numbers here. Total 72 outcomes, right? Agree? Say yes or no? Okay, now case 2. Case 2, 7 at hundreds place. Okay, 3 numbers. I have to place 1 here. 9 possibilities here, 8 possibilities here. Again 72. Yes or no? Right? Say yes or no?
Yes, sir.
Okay. Now case 3. Oh, sorry. This is at tens place, not hundred place. Tens place. Now 7 at hundreds place. Okay. So what I have to do at hundreds place? I have 3 possibilities. I can place 7 1 here, right? Only one 7 here. Okay. Now rest what I can do? I can place 9 numbers here. 0 to 9. I can place 9 numbers here. 0 to 9. Isn't it? Except 7. Except 7. Here 0 could not be put. So that's why there were 8 numbers. In the previous case also 0 could not be put. 0 could not be put. That's why there were 8 numbers. Here 9 numbers I can put. Here 9 numbers I can put. What is I am not putting, that is 7 should not be here. Because 7 should not be repeated. Do you agree with me? 81 outcomes. Total 72 plus 62 plus 81. It is 225 outcomes. Did you understand it? Put your thumbs up if you understood it. Very good. Good. Did you like the questions?
Time up, sir.
Time up, sir.
Okay. I was not playing a game. You are saying me time's up. Was I playing a game? Okay, you just write a homework question. You just write a homework question, and that's all from my side. For a set of 5 true false questions. 5 true false questions. No student has written the all questions. Okay, has written all correct answer. All correct answer. Okay. And no two students have given the same sequence. Has given the same sequence. Same sequence. Like if one is saying true, false, true, false, true. No two students are matching with the same sequence. Okay. Same sequence. All right. Of answers. What is the maximum number of students? Maximum number of students. Maximum number of students in the class for this. In the class for this possible. For this to be possible. Written. This is a good question. Try to solve as homework. We'll be solving more questions related to permutation in the next class. All right. Hope you liked the session. Okay. Thank you, everyone.
Thank you.